Hi guys, so today we're going to be analyzing graphs of quadratic functions, and what we did with our discovery lab on absolute value functions is really going to help you to compare your different quadratic functions. Yeah. So today, to do so, we're going to introduce to you a different form. Okay, as you can see, it looks pretty similar to that absolute value function. It's just instead of absolute value bars, we now have parentheses, and then we also have our square. Right, which makes it a quadratic. So in vertex form, it is y equals the quantity of x minus h squared plus k. Some of them might even have an a out in front, like you see here. Okay. And what it does, the reason why it's called vertex form is because it gives us the vertex very easily. It's h comma k. Okay. What it does is that h moves our parent graph to the left if h is negative, and to the right if h is positive. Okay. And then k moves it up and down. So if k is positive, it's going to be up. If k is negative, it's going to move it down. Okay. So we're going to start off by graphing our quadratic equation in vertex form. So here, what we're going to note is that this is really, so y equals a x minus h squared plus k. So this in our vertex form is really y equals a x minus negative 2. The reason why it shows up as plus 2 is because of that minus negative and then plus 1. Okay. And so what that tells us is that our vertex is going to be negative 2, comma, 1. Right, so this gives us our vertex. The vertex is at negative 2, comma 1, which is why often you hear students describing our relationship of h and k as opposite of what they see here. Okay, so vertex negative 2, comma 1. And what that means is compared to the parent function, right, compared to our parent function, what it's going to do is it moves our whole graph 2 to the left because h is negative, and so h deals with x's, right? And so then negative, that's towards the left. There's our negative numbers. And it's going to move our parent function up 1. Okay. So let's start by graphing things. So we're going to start with our vertex, which we know is at negative 2, 1. And so here's our vertex. And then, similar to when we're graphing in standard form, we're just going to plug in some x values after that. So negative 1, 0, 1, 2. I don't think they'll all fit, but we'll see what we can do. Okay. So plugging in negative 1 here. So negative 1 plus 2 squared plus 1. Negative 1 plus 2 is 1. 1 squared is 1. So this is 1 plus 1, which is 2. Then plugging in 0 for x, so 0 plus 2 squared plus 1. 0 plus 2 is 2, 2 squared is 4, 4 plus 1 is 5. Okay. The next one is 1 here, plugging in 1 for x. 1 plus 2 is 3, 3 squared is 9, and then 9 plus 1 is 10. So that's already the top, so this one's not going to fit. I can just ignore that. Okay. So since this is my vertex at negative 2, comma 1, the axis of symmetry is going to go through this vertex. Okay. Then graphing my next point, so negative 1, comma 2, so negative 1, comma, negative 2, comma 1 is here. I'm going to ignore that one. Negative 1, 2 is here, and then I'm going to mirror it over. Then it's 0, 5, then 2, 3, 4, 5, and then I'm going to mirror it over. And then 1, comma 10 is here, and then I'm going to mirror it over. Okay. And then I'm going to connect the dots. It should be a U-ish shape, and there you go. Okay, so why don't you try, check your progress 1 here, and then come check your answer when you're done. Okay, So what you should have noticed is that the vertex is at 3, -2. Again, we often think about h as opposite signs. So since this is x minus 3, right, and it's x minus h, that would make h +3. And k is going to be same sign, and so it's -2. And so what that means is compared to my parent function, this moved right 3 and down 2. Okay? So starting with my vertex then, I did the next couple of x values, so 3, 4, 5, 6. Plugged it in, I got 4, -1, 5, 2, and 6, 7, which I plotted on this side, and then mirrored it over and connected it into my U shape. Okay, so taking us through the next part, how does the value of a in the general form y equals a times the quantity of x minus h squared plus k affect a parabola? Okay, if you remember, okay, from our discovery lab on absolute values, what it does is that the sign of a reflects it. Okay, so here, if a is greater than 0, the graph is going to open up. It's going to be an upward facing parabola. If a is less than 0, meaning if a is negative, the graph is going to open downwards and be a downwards parabola. And the reason why is because it reflected it over the x-axis. Okay? And then what we also notice, remember from our absolute value discovery lab, is that a makes our graph, it basically stretches or compresses it vertically. And so if a is greater than 1, okay, it's going to look narrower compared to our parent graph. And if a, the absolute value of it, is between 0 and 1, it doesn't mean it's just a fraction. It has to be a fraction between 0 and 1, then the graph is going to be wider. Okay, and so then on page 287, it does a really nice summary of that for you there. Okay. And so that takes us to example 2. Okay. It asks us which function has the widest graph. Okay. So here, let's look at each of our a values. So here, a is -2.5. Here, a is -0.3. Here, a is 2.5 as well. Okay, and then here, a is 5. Okay. In terms of width, how wide they are, these two have the same width. The only difference is that this one opens down and this one opens up. Other than that, the width of them is the same. Okay. Then, what we should have remembered is that when it is between 0 and 1, okay, its absolute value is between 0 and 1, that's going to be the widest, okay? So this is actually the narrowest one because it has the biggest absolute value, right? 5 compared to the -2.5 and the 2.5. This one is going to be the widest one. Okay? So this one's going to be super narrow. Okay? And then this one's going to be big and fat. Okay? And that's because a is greater than 1. This is the narrower it will be. And then, if it's between 0 and 1, the wider it will be. Okay? So the closer to 0 it is, the wider it's going to be. Okay. So which function has the narrowest graph? You're going to do check your progress too, and then come check your answer when you're done. Okay, for this one you should have gotten D, and the reason why is because this one has the greatest absolute value. Right, so compared 0.1, 1, 0.5, and 2.3, this one is the biggest, and so that's why it will be the narrowest. Okay, so now this takes us to example 3. Okay? And what example 3 is going to do is it's going to have us rewrite this in vertex form. So right now you'll see that A and B are in standard form. Okay. And so to change it into vertex form, what we're going to do is we're actually going to complete the square. Okay. So there's several ways to do it. If you want, you can move the constant over in order to avoid dealing with it. Another way you can do it is you can separate it. by putting everything else in the parentheses and putting your constant outside. Okay? Then, what you're going to do is you're going to take b again. So in this case, that's 8. We're going to divide it by 2 and square it. Okay? 8 divided by 2 is 4, and 4 squared is 16. Okay? And what we're going to do, you can add it to both sides, right? But another way to do it, sometimes you're not allowed to manipulate both sides. So what you can do is you can rewrite it here as adding 16, but if I do the subtract 16, they cancel out, right? Because adding 16, subtracting 16 is really adding 0, adding nothing, and so that balances it out. Then I'm going to complete the square here. So this will be x plus 4 squared. Right? Again, we can check it. 4 squared is 16. 4 times 2 gives me that 8. And then let's simplify this. Negative 5 minus 16, that is negative 21. Okay? And so what this means here is my vertex is going to be at negative 4, comma, negative 21. Because again, h we often think about it as opposite signs. This is really minus negative 4. Right? And so what it means compared to the parent function is that we moved left 4 and down 21 compared to the parent function. Okay, so then let's try the next one. Right? So again, we're going to separate this. So negative 3x squared plus 6x. We're going to put our constant on the outside. Okay. If you want, you could add 1 here, but then you're just going to have to remember to move it back once you're done. It's up to you. Okay. Then here to complete my square, a isn't 1, so I'm going to factor it out. So this will leave me with x squared minus 2x. Okay. Right. This is why when we were learning how to complete the square, I told you not to divide it out because that's going to cause you more trouble now. So it's better to just factor it out. Okay. Then I'm going to take my b, in this case, negative 2. I'm going to divide it by 2 and square it. Negative 2 divided by 2 is negative 1, and negative 1 squared is 1. I'm going to take that 1, I'm going to add it here. Okay. But keep in mind, this isn't actually a 1, right? Because remember, this is actually negative 3x squared. This is really 6x. So here I actually did a negative 3. So to balance it out, I'm going to put a positive 3, right? Because this is negative 3 plus 3. It will cancel out to be 0. Right? Then I'm going to factor. So this becomes x minus 1 squared. Negative 1 plus 3 is 2. Right? Again, I can check if I did it correctly because negative 1 squared gives me 1. And negative 1 times 2 gives me that negative 2. And so there you go. So what this means, my vertex is 1, comma 2. Right? Since a is negative, it actually got reflected across the x-axis. Okay. Which is why, since a is negative, that's why it looks like this now. And then what happened, because this is no longer 1, because it's no longer 1, what we know is it also got narrower, right? Because this absolute value is greater than it got narrower. Okay. And what we know is that I moved right 1 and up 2. So here you go. Okay, so why don't you try check your progress 3a and 3b, and then once you're done, come check your answer. Okay, for 3a, you should have gotten y equals the quantity of x plus 2 squared plus 2. Compared to the parent function, the shape is the same. It's still facing upwards. However, since the vertex is now at negative 2, 2, it moved to the left 2 and down 2. For 3b, you should have gotten y equals 2 times the quantity of x plus 3 squared minus 1. Okay, the vertex has now moved to -3, -1. Because a now has changed and it's greater than 1, it has gotten narrower compared to the parent function, and it has moved left 3 and down 1. Okay. If you got that right, you can move on to example 4. If not, here is your explanation. Okay, so the first thing I did is I just moved the 6 out of the parentheses, my constant. Then I took my b value, which is 4, divided by 2, which is 2, and then squared it, which is 4. I added it here, okay? And to balance it out, since this was adding 4, then here I put a subtract 4, because really it's here on the same side, the plus 4 minus 4 undo each other. Okay? Then I factored this. This becomes x plus 2 squared. I can check this because 2 squared is 4, and 2 times 2 is 4. Okay? And then 6 minus 4 is 2. Okay? For 3b, the first thing I did is I moved the constant out and put the rest in parentheses. Then, since a is not 1, I factored it out here, so that's why I'm left with x squared plus 6x. Then, I took the b, which is 6, divided by 2. That gives me 3, squared it, and 9. So I added 9 here. But really, when I added 9 here, this is really 2x squared plus 12x. So then the 2 times 9 is 18. I actually added 18 here. So to balance it out on that same side, I subtracted 18. Okay. And then I factored this. This is x plus 3 squared. I can check because 3 squared is 9, but 3 times 2 is 6. 17 minus 18 is -1. There you go. Okay. So now on to our last example. We want to write an equation for the parabola shown in the graph. Okay. So we're going to do y equals a, x minus h quantity squared plus k. Okay. So first I'm going to look for my vertex. So here's my vertex. -1, 4. So that means this is h and this is k. And so I'm going to plug that in. So y equals a, x minus h is -1, and then square, and then k is 4. Okay. Okay. Then I'm just going to simplify that minus a negative really quick to be x plus 1 squared plus 4. Okay. Then what I'm going to do is I'm going to take this other point. So in order to solve for a, I'm going to plug this in for x and this in for y for the time being. So then I'm going to do 1 equals a, 2 plus 1 squared plus 4. Okay. So all I did is plugged in 2 for the x for the time being and 1 for the y. Okay. Now I'm going to solve for a. Okay. So 2 plus 1 is 3, so this becomes 3 squared plus 4. 3 squared is 9, so this becomes 9a plus 4. I'm going to subtract 4 on both sides. This becomes -3 equals 9a. And then get rid of the times 9 by dividing by 9. So this gives me -3/9 is a, or -1/3. Okay. So then I have y equals, a is now -1/3. H, again, is -1, so minus a -1, so that's why it's x plus 1 squared, and then plus 4 from my kid. And there you go. Okay. So why don't you try CYP4, and once you're done, come check your answer. Okay, you should have gotten y equals 5/4 times the quantity of x minus 3 squared minus 2. Okay. If you got that right, you can get started on your homework. If not, here's your explanation. Okay. So again, this is the generic form for vertex form for a quadratic. Y equals a quantity of x minus h squared plus k. Okay. hk is your vertex. So here, my vertex is a 3, -2. So I'm plugging in 3 for h and -2 for k. Okay. Then I just really need to find a. So to do that, I'm now going to plug in this other point on the line. So they gave me 5, 3. I'm going to plug in 5 for x and 3 for y for the time being. Okay. And now I'm going to solve for a. So 5 minus 3 is 2. 2 squared is 4. Then I'm going to get rid of the minus 2 by adding 2 to both sides. That gives me 5 equals 4a. And to get rid of the times 4, I'm dividing 4 on both sides. So that gives me 5/4 equals a. Now I have y equals a is 5/4. X minus h is 3. And then squared. And then plus k. And k is minus 2 or negative 2. Okay. That's it for today. Have a great rest of the day. Bye, guys.